here to help in an experiment which we have going on in the space station, which looks at how cubic particles, actually particles that are halfway between cubes and spheres, packed together to form crystals, with the object of understanding how geometry affects how you can organize materials.
Superball particles are different than the spheres because you can only imagine one crystal packing for a spherical particle, whereas cubes can take many different forms when they crystallize.
One of the really interesting ways of binding things together, it turns out, is to use DNA, which is not just the secret of life, but also involves separate chains which bind specifically together with one another. And when you heat them up, they dehybridize, they come apart.
We are using tiny little particles that are 200 times smaller than the width of a human hair, and we're trying to make them smart. We try to control their interaction, and by doing so, we can sort of force them to form larger structures, new materials, and an example is colloidal crystals. So this is something we do every day here on Earth, but the forces that these particles experience here on Earth are very often offset by the gravitational force.
The technique we're using to crystallize these particles is called depletion. On Earth, we always have the constant force of gravity pulling the particles down, so crystals happen in 2D arrays, something that's you could consider like a checkerboard, a two-dimensional array of cubes. We hope to see something that looks more like a Rubik's Cube in space.
The most interesting thing which we found in previous experiments in space is theory isn't always right. Theory is based on observations, and the observations that you make from things on the ground aren't always telling you the basic science, the basic physics that's important for understanding phenomena. So for instance, when we did experiments on the space shuttle, what we found is objects which were supposed to grow as spheres with a radius that just increases. That's what theory told us would happen. In fact, didn't do that. In fact, they were like snowflakes. They grew with arms, dendritic arms we call them, which grow out in an instability, okay, which was masked by the fact that on Earth, in gravity, these particles sedimented. In particular, in that case, for spherical particles. If we're lucky, we'll discover similar things for our particles which are no longer spheres. Spheres are the easiest thing. Now we want to understand what happens for more complex shapes. Okay? And so we want to see whether similarly the ideas we have from theory and from experiments on the ground hold up when you get rid of sedimentation due to gravity and you let these particles interact basically by their shapes and the interactions that they have with small particles around them which supply the pressure to crystallize them.